In this video, we look at higher order components as yet another pattern for sharing component logic. We learn about higher order functions in JavaScript and how this pattern can be incorporated in React as higher order components. Let's get started. Sharing and reusing logic and code is a critical subject, and when practiced well, will only lead to a cleaner and maintainable code base. Higher order components is another popular way to abstract and reuse logic across multiple components. The genesis of this pattern in React is credited to higher order functions, a fundamental programming pattern that is quite common. We know that functions in JavaScript are first-class objects, which means that they can be passed as an argument to a function and even returned from a function. Callback functions, for instance, are great examples of first-class objects because they are passed as arguments and returned from the functions as well. Here you can see the map method, which accepts a function as an argument. A higher order function simply operates on other functions by accepting them as arguments and returning a function. In doing so, you can augment the original function with extra abilities or even partially apply it using a closure. In a sense, we are talking about abstracting the inner workings and augmentations of the original function. Let's understand this with a quick example. Let's say we have a function called random array, which takes two arguments, namely length and multiplier, and returns a new array of the desired length with random numbers between 0 and multiplier -1 using the math.random function. If I run this function passing in a length of 2 and a multiplier value of 100, I get an array with two numbers randomly between 0 and 99. Now what if we want to create a version of this function which gives me just 5 numbers? We want to be able to lock down on the length as 5, so we can just set the multiplier. Let's do this using a higher order function. I'll build a function called withLength that accepts a given length and a function and returns a function that invokes the originally passed function with the length argument set. Notice how the rest of the arguments, that is multiplier in our contrived case, are being passed on using rest parameters. This now allows us to create a version of our random array function where we can set the length to 5 and 10 numbers respectively, as you can see here. We are passing in the random array function itself as an argument, and we get back a function with the length value locked in due to a closure. If I now run random5 with 100 as the multiplier, I will always get 5 random numbers between 0 and 99. Similarly, running random5 with 1000 gives me 5 random numbers between 0 and 999. Invoking the random10 function as expected gives me 10 random numbers with the given multiplier. This is how a higher order function helps augment a function with additional or partially set capabilities. When building React apps, you will come across situations where you would want to augment components with features and abilities that are common and shared. In the same way as a higher order function, you can build a component that accepts a component and returns a component, and in doing so adds extra and shared features using props. Let's run through an example to experience this concept in action. Begin by downloading and setting up the project first, and make sure you have the hot reloading server up and running as always. We have here a simple to-do list type application where the user can type in a task and it appears in a list. Users can also delete tasks by clicking the delete button here. But if I refresh this page, the data is lost. This app doesn't persist data in a database at this time. The app component is just a simple function component that includes an input field that stores its data in a state variable called task, which is then supplied to a self-contained list app component. This component encapsulates all that we need to manage a list of tasks and uses the children prop that allows us to implement the render prop pattern to customize the render logic. You can see we get two props, list and remove, which is all we need to render the list and remove tasks from the list. What I'd like to do now is plug in the ability to store and persist our list data in the browser's local storage. There are several ways to get this done, including the render props pattern, but let's build a higher order component. I'll create this component in a folder called services, which I find is a better strategy because ultimately this component is providing us with a storage service that we can plug in to our application. I'll then create a function component called withStorage that accepts a component and returns a function that receives props and returns an instance of the component with the props. This is what a higher order component looks like. It is a component that receives a component and returns a component with all the props as is. But this isn't any useful just yet, so let's add some capabilities. First up, I'll create a state variable called isAvailable that we'll use to flag the availability of local storage. Then I'll create a function called isStorageAvailable, which will use a try and catch block to assess the availability of local storage by storing and removing an item. The function does this if isAvailable is set to false, which will typically happen the first time this function is called. We get a true if local storage is available, and if not, we'll get a false. We'll then build two functions, one for reading data, one for saving. The onRead function accepts a key and returns back data from the local storage. We'll run the isStorageAvailable function to see if local storage is available, and if so, we'll fetch our data and return that to the user. If nothing's available, we'll return an empty array. The reason we are using json.parse is because we can only store strings in local storage, and structures such as arrays and objects must be converted to strings first. json.parse helps convert back stringified arrays to parsable arrays. Next, the onSave function again checks for local storage, and if so, it uses setItem to store the data as a string using a given key. These functions offer two brand new abilities that our list app component may want to use. To offer them to the component, we'll add two props, namely save and read, referencing our two functions. That's it. This is our storage adapter higher order component. Now to use this, we'll go back in our app.js file and import the withStorage service component first. Then we can create our new and advanced version of the list app component called list app with storage by invoking withStorage with an instance of list app like so. You can also do this directly in the listapp.js component file, but I'd like to have two versions here for demo purposes. Next, instead of list app, we'll render an instance of list app with storage here. Having done this, our list app component is now getting two new props, namely save and read. So let's go into the listapp.js file and we'll use the component.mount lifecycle method to first check for the existence of this.props.read, and if we have that available, I'd like to fetch data from a key called shopping_list. If and once I get this data, I'll set this to the list state variable like so. If we don't have this data, then an empty array works. This allows our app to use the storage adapter to load initial data from local storage for populating the list state array when the component loads for the first time. Likewise, our component did update function runs whenever a new task is provided to the task prop. As long as we get a new task string, we update our list state array with an object with an ID and the task string. In terms of data persistence, we'll simply check for the existence of this.props.save, and if available, we'll invoke it passing in the updated list with the shopping_list key. Likewise, when an item is removed, we'll once again run the save function using this.props.save to save the updated list to local storage. Adding these statements means that we can use the list app both with and without the storage adapter component. We have already added our storage superpowers to the list app component. So now when we add new tasks, you can see they persist nicely even after I refresh the browser. And you can always use the list app without the storage ability like so, and as expected, data doesn't persist. It is important to note that higher order components should never be created inside the render method. Not only does it affect performance, but it also kills any internal state that the higher order component may have been maintaining on every re-render of the component, which is never desirable. Creating the higher order component outside, just as we did in our example, will create a single and consistent instance of the component that maintains state and children as desired. You also need to consider prop name conflicts with existing props that the wrapped component might have in its own implementation. This is why render props may be a better pattern for achieving code reusability, and a possibly better pattern involves the use of the HOCs API. Having said that, the higher order component pattern is extensively used. Both Redux and React or Reach router packages use this pattern for integration. As an experiment, try implementing our storage adapter using render props.